Let me show you how to use Desmos to sketch the graph of a function, and then by looking at the graph, we will point out the solution of the function. All right. So before we start, Desmos is this app is completely free. You can download it on App Store, Play Store. You can do this on your iPad or your phone. So if you don't have an iPad, you can do this on your computer. So just look it up on Google, and then you can just do it on your computer. Again, this is completely free. All right. So whenever you pick up a problem from a textbook, please take a look at the first line on the left hand side of the screen. So the first line, do you see that? The first line, I have 3 over x plus 2 equals to 1 over x. I want you to graph these equations on Desmos and then find out the solution, which is what x equals to. All right. So when you see this problem, most people will just, oh, all right, so I will just go to Desmos and then just plug it in. Okay, so we have 3 over x plus 2 equals to 1 over 2x. All right, and then you see, okay, so on the right hand side of the screen, I see a graph. Is that it? The answer is no, that is not it. So whenever you see a equation written like that, the first thing that I would like you to do is I would like you to move all the terms to the left hand side, right? So moving all the terms to the left hand side, that means I would like you to subtract 1 over 2x on both sides, and then after that you have line 2, right? Do you see that? Line 2 on the left hand side. So on the right hand side, you have that equals to 0. And then you are going to ask me a question. Okay, so can I graph that now? The answer is not yet, because if you just type exactly what you see on a textbook, that is not the right graph. In fact, to get to the right graph, you have to eliminate the equal and a 0, so which is line 3. So line 3 is the graph of the function. Do you see the graph? This is exactly what I want you to do. So once again, this is the same thing as having a y equal. So if you do a y equal, that is completely the same. If you don't type y and the equal, then the system assume that that is y equals 2. All right, so let's get rid of that. Okay, so now I have the graph. What is the solution? The solution is x equals to what, such that the equation you see on the first line is balanced. Look at the first line, 3 over x plus 2 on the left hand side, and then equals to 1 over 2x on the right hand side. So what is x equal to? The answer is just tap on the x-intercept. Do you see this? There is an x-intercept. When you tap on it, by the way, what is an x-intercept? X-intercept is a point on the x-axis. Is a point on the x-axis. So x equals to 0.4, y equals to 0. This is a point on the x-axis, and this is also a point on the graph. This is the solution of the equation. And then you might ask me, hey, so it looks like if you look to the left hand side and right hand side, maybe the graph will just cross the x-intercept. All right, so let's go take a look. So if you look all the way to the left, as x approaches to negative infinity, so if you go all the way to the left, as x approaches to infinity, do we agree that the curve is getting closer and closer to the x-axis? All right, so that is what happened when you look all the way to the left. How about the right hand side? So let's look all the way to the right hand side. What do you get? You see that the graph comes up and then goes across the x-axis at 0.4 comma 0, and then go up and then go back down. So as x becomes a very large value, the curve is approaching to the x-intercept, but it looks like the curve will not cross the x-intercept as x approaches to positive infinity. So what happened is, once again, x equals to 0.4 is the only solution of the equation you see on line 1. And then what happened on the x-axis? The x-axis, what is x-axis? X-axis means y is equals to 0, right? So I'm going to add y equals to 0. Do you see this? As x getting closer and closer to positive or negative infinity, the curve is approaching to the x-intercept. X-intercept means y equals to 0, because on the entire x-axis, y is equals to 0. And then we call this a horizontal asymptote. Horizontal asymptote. So when people graph horizontal asymptote, if you never heard about the word before, don't worry about it. Just take the word for me, horizontal asymptote. Because later on in the future lessons, we will discuss more details regarding horizontal asymptote. So horizontal asymptote, they usually use a dash line. So the way we change that to a dash line is we hit the gear icon. Do you see this? There is a gear icon. And then I am going to change this to a dash line. So that is a horizontal asymptote. If you make the line look bold, so you can use a bigger value instead of 3.5, you can change that to 4. So like now the line looks bold. Okay. So what else do we need to know? Because the job is done. We have the graph, we have the solution. The solution is equals to 0.4. Okay, so the solution is equals to 0.4. What else do we need to know? Now, take a look at the first line. Do you see that in the denominator, we have x plus 2. So what happened when you have x plus 2 in the denominator? You have to tell yourself that, well, x plus 2 cannot equal to 0, right? Cannot equal to 0 because when you have a 0 in the denominator, the fraction is undefined, right? You cannot take a 3 divided by 0. So that means in order to not have a 0 in the denominator, x cannot be equal to negative 2. So what happened when x is equals to negative 2? So when x is equals to negative 2, let me graph that. When x is equals to negative 2, so you have this, and then I'm going to change the color. To change color, you have to hit the gear icon, and then you can change that to what color you want. So let's use a dotted line. So what happened when x is equals to negative 2? If you look all the way down, as x approaches to negative 2 from the left hand side, do we agree that y is dropping to negative infinity? How about the other side? As x approaches to negative 2 from the right hand side, y is getting really big, which means y approaches to positive infinity. In another words, x equals to negative 2 is a vertical asymptote. If you never heard about the word before, don't worry about it. Just take the word for me, because in the future lesson, we will have a more detailed discussion regarding vertical asymptote. So there is one more vertical asymptote. Again, go back to line 1. Do you see on the right hand side of the equal, there is a 1 over 2x? Do we agree that x cannot be equal to 0? Am I right? X cannot be equal to 0, right? So what happened when x is equals to 0? X is equals to 0. Of course, I'm going to hit the gear icon and then change that to a dotted line. Do you see that? X equals to 0. So when x is equals to 0, which is on the y-axis, what happened as x approaches to 0 from the left-hand side? Do you see that as x approaches to 0 from the left-hand side, follow the purple curve, y is getting so big, so y is approaching to positive infinity. How about the other side? As x approaches to 0 from the right-hand side, do we agree that the curve drops all the way down to negative infinity? That means y approaches to negative infinity. So that is the second vertical asymptote of this equation. Okay, now let's go back to what I discussed at the very beginning. So we have this, the first line. You take that straight from the textbook. Don't just input that to Desmos and then call that the graph. No, that is not right. In order to see the correct graph, you have to move all the terms to the left hand side. So the right hand side is equals to 0. And then after that, eliminate the equal and the 0. Just graph what I did on line 3. So line 3 is the graph of the entire function. So if you zoom out, the graph looks like this. And then on your decimal, sometimes you don't see the grid. It's one step at a time. So you have to hit the icon on the right hand side. You have to change the step to a 1. Change the step to a 1. After that, each box is just 1 unit to the left and then 1 unit to the right. So you can zoom in, you can zoom out. Very convenient. In order to point out the solution, which is what x equals to, so you have to find out, okay, so the graph crosses the x-axis at this point, so x equals to 0.4, is the solution of this equation. Alright, so that is the end of this video. If you like the way I explain graph using decimal, give this video a thumbs up. If this is something that you want to see, subscribe, stay tuned for more video in the future. As always, I will meet you all in the next lesson. Signing out.